Alright, so we're going to be looking at this problem. This is a very common physics calculus type of problem, and a lot of people just don't really like these types of problems, so I'm going to try making it kind of easier to understand, make logical steps that maybe you'll actually find these problems much more easier, right? So, yeah, let me just see. So, a bow shoots an arrow straight up with a launch velocity of 160 feet per second. Its position is described by the function s of t equals 160t minus 16t squared, where t is in seconds. How high does the arrow go? What is the velocity? So velocity, speed, acceleration, you have a lot of things happening, a lot of parts, and usually it would be on a test, maybe it might be given as like a free response question, right? One idea with multiple parts. Since we're talking about velocity, speed, acceleration, it might be helpful just to find the functions that describe them, right? So I'm going to do that in red. So we know s of t is equal to 160 t minus t squared. So its velocity is just the derivative, right? Velocity is just the derivative of s. And we can just use the power rule to find that out, right? So bring the power over. This is 160 and then this is 32t, right? And then we want to find the acceleration, which is known as the derivative of velocity, which is also the double derivative or the second derivative of the position, which is the constant goes away. So here, let me write it like this. The constant goes away, so it's negative 32, right? 32. And these functions are really helpful, so especially when we go through this problem, so it's good to keep this in mind. So I'm going to do A here. A I'm going to do in purple. So how high does the arrow go? So it's good to think about what do you mean by how high does it go, right? When you launch something in the air, you would let's say I launch it, right? And then its trajectory looks something like this, right? Kind of like a parabola-ish shape, and it makes sense because the position function is a parabola. But there's this maximum point here. This is what we're trying to find, right? So what this point is, what's something about this point that makes it unique, right? We know that the position is something. What's the acceleration is always negative 32. What happens at this high point? Is there anything special? Well, the thing that's special is that the velocity is 0 at this time. The velocity is 0, no matter what, right? It's not, at that exact moment it reaches the peak, it is not moving up or down anymore. It's like stationary for just like a split second, an instantaneous second, and that's the important part. So, let's look at that. V of t equals 160 minus 32t. We want to set equal to 0, and we want to find what t is. So t is equal to, what is this? So we have to bring the 160 over and divide by 32, negative 32, so we are left with 5, right? We could easily solve equations. So the velocity is 0 at t equals 5 seconds. That's helpful so we know what the position is, right? T equals 5 is a very crucial part of the problem because it tells us that the 5th second is going to be at its highest position. Let's actually plug that into the position function. So 160 times 5 minus 16, 5 squared, which is, according to the calculator, it is 400. 400, and we have to keep in track of the units, right? Position, I mentioned feet per second. You should probably think of feet as feet. So that's the first question. I'm going to leave it up for a little bit, and then we're going to look at the second question. Now, part B. What is its velocity? What is the velocity at 5? Well, I mean, obviously from the previous example, we know at t equals 5 seconds, the velocity is 0, right? So we can easily finish that up really quickly, but the point of this is not just finding the velocity for any specific time. you kind of want to find it for any time, right? If I give you time equals 2, for example, let's actually just do 5 just to show. So we have to plug in 5 into the function. So 160 minus 32 times 5, which is 0, right? 0 feet per second. But the point of this is, given any time, can you actually find the velocity? Let's try it. Let's do t equals 2. So v of 2 is equal to 160 minus 32 times 2. 160 minus 64 is 96. 96 feet per second. What about t equals, we can do it for any time, right? T equals, let's do 6. V of 6 is equal to 160 minus 32 times 6, which is negative 32, I believe. So we can find it any time. So as long as you know the velocity function, which can be found using the position function, right? The derivative. So that's how we do B. On a test, it might be any time and any function. So your job is to know the derivative and how to just simply plug in a number in. So, alright, part C is actually, you need part B to answer. So the speed, right? We know the speed from the velocity from part B is 0 feet per second. So the speed is the absolute value of 0 feet per second, which is actually just 0, right? But again, like the last problem, we should be able to do it for any time we like, right? It's not just the one the question's asking, because then you're just memorizing steps. We should be able to actually know how to do it for any time. So let's try it again. Let's do the 6 example. So when t equals 6, I remember from the previous example, the velocity is 32 feet per second. So what is the speed at 6? Speed, that's not how you spell speed. Speed at time equals 6 is the absolute value of negative 32 feet per second, right, which is 32. Right, so any time is just, that's what the speed is. It's the absolute value, or just the positive version of it. So that one wasn't actually an easy one. It's also 0. But you should be able to do it for any time I give you. What is the acceleration at any time t, right? Acceleration, you have to think of the derivative of the velocity function, which is here, right? So let me just write it down. A of t, this is part D. A of t is just equal to negative 32. It's not really dependent on time for some reason, right? And that's kind of weird. So that's why the question is saying at any time t, right? It's always going to be the same. If you plug in a of 0, it's going to be negative 32. If you plug in a of 3, it's going to be negative 32. So, but the units have to be feet per second squared, right? Feet per second squared. Feet per second squared, right? And think of this as every second the velocity is changing by negative 32 feet per second. Every second. So that's why it's feet per second per second. And now the final question. When does the rock hit the ground? What time does it hit the ground? This is kind of a hard problem for many people because they don't know what to think, right? Kind of like A. A was kind of weird because we had to find something special. The velocity had to be 0. When does the rock hit the ground? That's kind of a interesting question, right? So let's just do it. Let's just see. If I were to draw the ground, right, and then we shoot the arrow, it goes up and it goes like this. Let me draw a more parabola-like shape just to help us. Something like that, right? What's special about hitting the ground here? Well, the thing that's special is that the position, right? We're thinking of vertical position up and down. This is position equals 0. And this is position equals 400. So we want to find a time where position is 0. That's kind of an interesting thing. So we want to actually set this equal to 0. And you can go about this many ways. You can graph it on your calculator and find the zeros of the function. You can use the quadratic formula. You can factor. I'm just going to do the easiest one for this one that I can show to you and just factor it out. So factoring it out is pretty simple. What you want to do is find the GCF, which is 16 on both sides, or for both terms, 16t, right? So 16t, we're left with a 10, and we're left with a t equals 0. So now we want to solve for t. T can equal 0, or it could equal 10, right? Sometimes in these problems, the functions give negative time, and that's kind of weird. Can you go back in time? So usually for those, you would have to get rid of it, or just like ignore it, because there's no such thing as negative time. It's always going forward. So t is equal to 0, and t equals 10, so does it hit the ground twice? It doesn't really, because notice where it starts. It starts at position 0, right? That's time 0, right? So it does its thing. At time 5, it reaches its max height, and then at time 10, it reaches the ground. So the one where it hits the ground should be time equals 10. So this is the one we should be focusing on. T equals 10, right? So I am going to just simply plug it in. Plug it into the function s of 10. This is where everything comes together. 160 times 10 minus 10 squared. And let me just type that into my calculator. And let's see. Minus 16 times 100. That is, well, 0. Right? So it makes sense, right? We plug in 10 and we get 0, so it's at its position 0. Just to confirm our belief that it is time 10. So, it hits the ground at time 10 seconds, and we're basically done with this problem. It was kind of long, and a lot of people just don't like this problem because, or these types of problems, because it's like so many terms: velocity, speed, position, acceleration. Oh, at the top it's this, at the bottom it's this, you have to solve for t, you have to do all this. It's just a lot to handle. But hopefully this just gives you a general idea of how to solve these types of problems, because most of it is just noticing the facts, or like the fact of something. So I'm going to write a quick summary of motion like this. So when you throw something in the air like this and it makes, let me draw it in better, you throw something in the air and it makes the parabola shape. Here is the max height. Something special about the max height is that the velocity is 0. This is the ground. Here and here are when its position is equal to 0. And on Earth, usually the acceleration is pretty much constant, so that might be helpful. Acceleration on Earth is constant, but some problems won't set it up as the acceleration being constant. Sometimes it's actually a function, like if acceleration, or if the position function is a trigonometric one. But on Earth it is a constant. It's in feet is negative 32 feet per second squared. In meters it's negative 9.8 meters per second squared. So those two, if you ever take a physics course, you'll be learning a lot about that and understanding more about projectile motion, or this type of motion that we're talking about. But just know these are the key things, especially this, and then you should know how they're all related. S, you take the derivative, right? You get V. You take the derivative again, you take A. And this should be what you should take away from this video, and using these facts to help you in your problems.